Welcome. We're very excited to have you here today on this last day of reInvent, and we hope you've enjoyed the sessions and the content that was presented this week. My name is Bassem Bashay. I'm a Senior Technical Program Manager on the AWS Storage Gateway team, and I am joined today with my two colleagues, Nida from the Snow Family team and Matt from the Global Social Impact team. And today's session, we're going to be covering several AWS services that customers use to bring AWS to their on-prem and edge environments. So let's look at the agenda. So during this session, I'll start by covering a continuum of AWS services from cloud to edge. Here we'll understand the basics of how we support edge services at AWS, beginning with Storage Gateway. And later, I'll invite Nida to come up and talk about AWS Outposts and the Snow Family. And as always, we're happy to take questions at the end, and feel free to meet with us after the session as well if you have more questions. So at Amazon, we always start everything with working backwards from our customers' needs. So we speak to a lot of customers and listen to what they have questions about and what they're asking for. And what they've been telling us for many years is they need solutions that extend all the benefits of AWS infrastructure and services to wherever they need it, with the flexibility to run their applications in cloud or on-prem or at the edge. So we've recognized that there are a lot of use cases that need to stay on-prem, and we have been working on many services that can help bring AWS to those on-prem and edge environments so that customers can use the cloud capabilities where they need it near their applications. So as I said, customers are looking for solutions to provide that same experience across the cloud, on-prem, and edge. And regardless of where their application resides, they want to use the same infrastructure, services, APIs, and tools. And they really want a continuum of consistent cloud services that extend from regions to their on-prem and remote locations. And that allows them to operate seamlessly across a multitude of environments. The bottom line, customers really want their teams not to be distracted by learning new tools or dealing with new operations. They want builders to be free to focus on building. So with that, and with those learnings, we've worked on several AWS services, and some of them we'll cover today, that provide customers with AWS technology near their applications. So we'll start with AWS Storage Gateway. As I mentioned, today there are many applications that need to stay on-prem for one reason or another. That could be due to compliance or regulatory reasons, so they can't be moved to the cloud, or maybe due to the complexity of migrating those legacy applications because they would need to be re-architected for the cloud. So we've had customers ask us for ways to continue using their on-prem applications, but be able to leverage cloud storage for its low costs and durability and scale. Essentially, they asked us to bridge between their on-prem applications and the data stored in AWS Cloud Storage. And that is where Storage Gateway comes into play. Storage Gateway is a hybrid cloud storage service that provides on-prem application access to virtually unlimited cloud storage. And some of the challenges that customers have faced and have talked to us about, some of them are on the screen in front of you on the slide, and they basically are summarized in some categories. Customers say, I have complex on-prem applications and databases, but I want to leverage cloud resources and its scale. or I need to be able to access my applications locally, but want to take advantage of cloud compute and analytics engines. Or I have years invested in security and compliance requirements and processes and procedures to accommodate that, but I want to leverage cloud management and monitoring capabilities, ideally from a single pane of glass. Or I have multiple locations and I want my connectivity to be reliable and easy to maintain, but I have so many physical locations to manage where I've got data and applications. So there's a multitude of challenges that customers have told us about, and they're looking for solutions that can help them with those challenges. So we've taken those requirements, those needs from customers, and designed several services to cater for those. And I'll start by talking about Storage Gateway in more detail. So Storage Gateway is really a family of gateways. There are 4 different types of gateways that are offered, and they're really all designed to fill in a need or meet a requirement based on the use case and workload that the customer has. So we'll start with the first one, which is our Amazon S3 file gateway. And that gateway provides native file access through SMB and NFS shares. And the data that is stored on the gateway through an SMB and NFS share is then stored in S3 in the cloud. So this is a great solution for backups, for archives, for data lakes, and it's one of our most popular gateways. And one of the very unique features of this gateway is that every file that is saved on an SMB or NFS share is then turned into an object in S3. And it can then be used downstream by other services within AWS for analysis, for machine learning, and so on. So it's very beneficial for customers to use it in that form. Next is our Amazon FSx file gateway, which provides file access to FSx for Windows file systems. And this is a great solution for group file shares and home directories, and essentially provides low latency on-prem access to FSx for Windows file systems that are in the cloud. Next up is our tape gateway, and that enables customers to replace physical tape infrastructure with virtual tape libraries in AWS instead. So customers, instead of storing their archives on-prem, on physical tapes, they can store them in AWS and take advantage of the low cost of Glacier Flexible Retrieval or Glacier Deep Archive. And last but not least is our Volume Gateway, which provides block storage access to cloud storage. And you can create EBS snapshots for point-in-time recovery of your volumes in the cloud, which is a great use case for disaster recovery and backup workloads. With all of those gateways, and as I mentioned, customers wanted to leverage cloud capabilities, but still be able to deploy those on-prem without making changes or modifications to their applications. We've designed those gateways to really be plug-in into the existing environments. And what that means is the gateways provide standard protocols. For example, it's using NFS, it's using SMB, iSCSI, and iSCSI VTL. We also provide a local cache with every gateway. And what that does is it provides low latency performance for frequently accessed data, while changed data is uploaded to the cloud in the background. We've also implemented optimized data transfers to minimize network traffic, and that essentially saves costs for customers. And as I mentioned earlier, there are many customers that have regulatory and compliance requirements. So we've made sure that the Storage Gateway service is certified for all the common regulatory certifications that are needed, and that includes FIPS, HIPAA, PCI, SOC, and many others. And as with any AWS service, it's a pay-as-you-go service. So you really only pay for what you use, and it's also integrated with all the AWS tools and services that you would use to monitor and manage your AWS infrastructure. This is just a small sample of some of our customers, and what I really wanted to highlight with this slide is to show you that our customers are global, and they range from size and industry. So there are many small customers as well as large enterprises, and we have customers across many verticals, from pharmaceuticals to financial services to high tech and so on. Also, education is a big vertical that we see a lot of adoption in. So let's take a look at some of these customers and look at how they have leveraged Storage Gateway to overcome some of their hybrid cloud challenges. I'll start with Moderna. A few years ago, Moderna was not a name that many people recognized, but I think in the past 2.5 years or so, it has become a household name. So Moderna has been a long-term user of Storage Gateway ever since they were a small startup in Cambridge, Massachusetts. And they really made a strategic decision early on to leverage AWS for processing and analyzing all of their scientific data. And as you can imagine, when they started embarking on developing a COVID vaccine, they really needed to scale, and they needed to scale fast. And Storage Gateway was instrumental in getting their infrastructure scaled up. They simply were able to just scale up their existing gateways, add more gateways as they needed them, and it's been a true success story for them to be able to keep up and be agile and work on developing the COVID vaccine very fast. Next is Kellogg's. Kellogg's is, again, another household name. Many of you know they make lots of cereal products as well as other things. And Kellogg's was dealing with an exponential growth in their on-prem databases that they really needed to back up. So they were using on-prem backup solutions to back up their existing Oracle and SAP databases, and they couldn't continue to do this on-prem. It was not sustainable. The cost and management of that infrastructure was too much to handle. So they embarked on using file gateways as their backup target for their databases, and they were able to migrate a lot of their backups in a fairly short period and really eliminated 90% of their existing on-prem backup solution and saved a lot of money that way as well. Next customer story is Ryanair, which is an airline based in Europe. And Ryanair had a lot of on-prem tape infrastructure that they were archiving their data locally and then sending those tapes offsite for storage, long-term retention. And they had many problems whenever they needed to restore data from those tapes. In many cases, they experienced failures. So it really wasn't working for them as a solution. It was costly, it was time-consuming, and it was not reliable. And in a remarkable short period, they were able to migrate their backup solution from physical infrastructure to a virtual tape library with Tape Gateway. And that saved them 65% of what the cost they were spending, and also gave them the reliability and speed of doing backups and restores. And the last example I use is Exact Sciences. Exact Sciences is a fairly large company that is really producing a large amount of next generation sequencing data for genomics. And they have labs all around the United States and international as well. And they produce a lot of raw data on-prem. and need to send that data to Amazon S3 for analysis and downstream processing. And they needed a solution that can scale quickly, that is low cost, and is easy to manage. So they started testing and deploying the Storage Gateway hardware appliances, and quickly realized that that's a solution that really fits within their needs and works very well in their environments. And they quickly expanded their deployment footprint, and now they have many of those hardware appliances deployed running Storage Gateway at their labs. And that allowed them to seamlessly transfer hundreds of terabytes of data into AWS so that they can analyze it and process. So how do customers really deploy and use AWS Storage Gateway? So the gateway comes in multiple formats based on the customer needs and their environment and how they want to deploy it. So many customers will use our virtual machines, and we have versions that come for VMware, Hyper-V, and KVM. Customers can also deploy Storage Gateway in EC2 and run it in region, or they can purchase our pre-configured hardware appliances, which come preloaded with the Storage Gateway software. And earlier this year, we've changed the procurement process for the hardware appliances to make it easier for customers, so now customers can buy the hardware appliances from their preferred reseller of choice. On the availability side, you can run Storage Gateway in high availability mode in VMware environments. So we leverage the high availability features of VMware to provide high availability for the Storage Gateway. We're also available in all the AWS regions, as well as GovCloud. So pretty much wherever you need to run Storage Gateway, the service is available. Some of the security and compliance features that we have, we provide audit logging for NFS and SMB file shares. On the tape gateway side, we provide warm and tape retention lock. We also have FedRAMP high and moderate certifications for our government customers. From a scale perspective, you can scale the cache within any of the gateways up to 64 terabytes, which gives you plenty of storage close to your applications so that you can cache the frequently accessed data. We also provide schedule-based bandwidth throttling, and we continuously enhance the performance by providing continuous updates to the Storage Gateway software. With that, I will conclude the Storage Gateway part, and I'll invite Nida to come and talk about AWS Outposts.
Thank you, Bassem. Hello, everyone. Good morning. I am Nida Beg. I'm product lead with AWS Snow Family. And today, in addition to some of the use cases that Bassem outlined for hybrid edge cloud storage and compute, I'll be talking about AWS Outposts and AWS Snow, specifically about how AWS is extending the boundary of the cloud to the edge with these two services. Later, I'll invite Matt Johansson from AWS Disaster Recovery to talk about applications of Snowball Edge for disaster response use cases. Before we kind of move on, a couple of things that you'll take away from this session specifically. The first one would be a clearer understanding of the AWS cloud to edge continuum. The second thing that you'll take away with you today is a deeper understanding of two AWS hybrid edge services, namely AWS Outposts and AWS Snow Family. And the last thing that you'll take away with you is a deeper understanding of the use cases and how our customers are using Outposts and Snow for their hybrid edge use cases. All right, so let's talk about Outposts. Outposts was announced in 2018 and launched, and essentially enables developers and developers and customers to develop their applications once and deploy in the AWS cloud or on-prem without having to rewrite their applications. So what's essentially happening is that customers can use the same AWS applications or build their applications just once and use the same application on premises and in cloud. AWS Outposts runs with connectivity back to an AWS region, which basically means that it provides you with the same set of capabilities and tooling that you're used to using in the cloud on premises. With Outposts, you also have the same hardware and software infrastructure, and like I said, a consistent set of services and tools across your AWS cloud and on-prem environments to build and run modern cloud-native applications anywhere. AWS Outposts is essentially a family. It consists of fully managed solutions delivering AWS infrastructure and services to virtually any on-prem or edge location for a truly hybrid experience. Outpost solutions allow you to extend and run AWS services on-prem and is available in a variety of form factors. The first one is the 42U Outpost Rack, which brings the same AWS API services and features to virtually any data center or co-location space. The second is the 1U and 2U Outpost servers, which is well suited for space-constrained use cases. Right, so in scenarios where you require where you have smaller capacity and you want to maintain the same low latency workloads and requirements, you also have the option to use the Outpost 1U and 2U Outpost servers. One of the things that we've been hearing from our customers was to bring the same cloud compatibility or the API compatibility on Outposts. With connectivity back to an AWS regions, customers can do that today. So what that means is that customers can use a bunch of AWS services on Outposts, namely Amazon EBS for block storage. Customers can use Amazon S3 on Outposts for file storage. Customers can use Amazon ECS and EKS to run their containerized workloads. And customers can also use Amazon RDS and Elasticache to run their highly available and highly performant databases. And these are just to name a few services that are available locally on AWS Outposts today. Let's look into one of the use cases for AWS Outposts and how our customers leverage Outposts for their use cases. One of the customers that I'll talk about today is NASDAQ. NASDAQ is one of the most popular names in the stock exchange and the stock market. And because NASDAQ's markets are responsible for seamlessly transacting hundreds of billions of dollars a day, serving millions of investors globally, the underlying market infrastructure really needs to be hyper-scalable, ultra-resilient, and highly performant with ultra-low latency. What this means is that NASDAQ required operations that were running super close to kind of where the data was being tracked and trained. Outposts was used to uniquely provide NASDAQ the ability to use consistent AWS infrastructure, services, APIs, and tools across AWS regions and on-prem. That means NASDAQ can now leverage AWS's cloud capabilities to deliver innovative anti-financial crime, data and analytics, and market infrastructure solutions to its global clients wherever those workloads need to run. With the use of Outposts, NASDAQ was able to process end-to-end order-to-trade transactions, and they were able to reduce that from double-digit to microseconds with a 10% performance improvement in network latency. But one of the things that we've been hearing from our customers, many customers, that having on-prem infrastructure isn't enough for them to reach all the edge locations where they are running their operations and to process their data at edge locations. So one of the other services that we have within the AWS Hybrid Edge portfolio is the AWS Snow Family. AWS Snow Family of devices enables customers to deploy AWS-based solutions to capture, process, and to move data from rugged mobile edge locations to the cloud. What do we mean with rugged and mobile edge locations, right? On-prem is with Outposts. Customers really have the ability to connect back to AWS in region and have that same API compatibility and run their operations seamlessly. But when you're looking at some really remote locations where customers have limited to no connectivity back to an AWS region, such as construction sites, oil platforms, or mobile environments such as ships, autonomous vehicles, airplanes, and even rapidly deployed military forces, our customers are really running operations at the edge of the edge. And what we've done to kind of meet our customers where they are is we've taken this infrastructure to even the most extreme environments. And yes, even to space. We'll talk about that in just a bit. Like the Outposts family, Snow family also consists of a set of devices. The first device that we'll talk about is the AWS Snowcone. AWS Snowcone is the smallest member of the AWS Snow family. It's the size of a tissue box, and it's extremely portable, ruggedized, weighs about 8 pounds. It's available in 2 flavors. The first one is the HDD variant, and the second one is the SSD variant, which was launched recently. Along with that, on the Snowcone, there's about 2 to 4 usable vCPUs and up to 15 terabytes of storage on these highly portable devices. The second family of devices that we have within Snow is the AWS Snowball. AWS Snowball is also available in a couple of flavors. The first one is the compute optimized that will enable you to run dense AI/ML workloads or integrated RAN and 5G core workloads in remote ruggedized locations. And the second one is the storage optimized devices for use in extreme locations. Now, with access to Snowball Edge and Snowball and Snowcone offerings, customers can now run capabilities that are designed to operate in the most extreme conditions. Not just that, with the existing capabilities and the amount of storage and compute that's available on the devices today, you can also group AWS Snowball devices to get highly available storage capacity in the most ruggedized locations, such as mobile platforms, trucks, and aircrafts, to run, again, AI/ML, super dense AI/ML workloads, integrated RAN, and 5G core workloads. Let's dive a little deeper into what kind of capabilities are available on the Snow devices. Snow family is another extension of the AWS infrastructure and services, where you can run a select set of AWS services on the rugged edge and in disconnected locations. Some of the services that you can run are AWS IoT, you can run storage, you can run ML on Snow devices, compute and containerized workloads on Snow devices with a mobile ruggedized edge. With Snow, the idea is really to enable customers to deploy and operate in AWS environments without needing to connect back to the internet. Let's dive into 2 of these services on Snow devices. The first service that we'll talk about is AWS Snowball with Tape Gateway. At re:Invent last year, we announced AWS Snowball with Tape Gateway, making it easier for you to do offline migrations of data stored on physical tapes to AWS. We've been continuing to enhance and improve these capabilities to meet our customers' needs. And last month, we increased the maximum supported virtual tape size on Tape Gateway from 5 terabytes to 15 terabytes, enabling you to store more data on a single virtual tape, reducing the number of tapes you need to manage. The other service that we'll talk about is Amazon EKS Anywhere on Snow coming soon. Amazon EKS Anywhere on Snow really enables customers to run their containerized workloads at the rugged disconnected edge. Our customers told us that they need to bring the same cloud applications that they're running in AWS to the rugged edge with limited to no connectivity sort of workloads. With EKS Anywhere on AWS Snow devices, customers can deploy their containerized applications to the ruggedized disconnected edge with a consistent Kubernetes operation experience in a fault-tolerant and a highly available manner, enabling you to bring your applications, containerized applications from the cloud to the edge, and run operations in a seamless manner, and leverage the same APIs that you're used to using in the cloud. Let's look at some of the applications of how our customers are leveraging AWS services that are available on Snow devices today for some of their use cases. We'll dive into 4 use cases. The first one that I'm super excited to talk about is the work that we did with one of our ISVs, Mavenir, which is a 5G ISV that offers a fully containerized packet 5G core portfolio to modernize existing mobile networks. Mavenir's customers Spark and Curious wanted to build a hazard detection system for Environ NZ in New Zealand to help detect if people are too close to excavators in their busy waste extraction or like a waste management setup that they had. With kind of partnering with all of these ISVs and customers that we work with, Spark now has access to a hazard detection system running on Amazon EKS Anywhere on Snow devices with a combination of AI-powered computer vision solution built by Curious and containerized 5G core solution built by Mavenir. In this picture, you can see how at a waste management center, how the AI/ML algorithm is kind of working. All of this is being run and managed on AWS Snow devices, running containerized applications. The second use case that we'll talk about is also a telecommunications use case, where the Norwegian army required a mobile wireless network for secure communications during search and recovery operations that they were running in a rugged edge location. What we did was partner with Telenor to deploy a private 5G network that was running Athonet, which is another ISV. So it was running the Athonet 5G core on Snowball Edge devices to provide a mobile secure communications network to enable search and recovery efforts in a fully disconnected fashion. We continue to see exciting use cases where customers are using Snow devices either to create private 5G networks, to run their AI/ML applications containerized for hazard detection systems. One of the exciting use cases that we have on the Snowcone side of things was the work that was recently done, like I said at the beginning of my talk, was to push the boundaries of the edge with AWS Snow to most extreme environments. In this use case, I'm going to talk about how Axiom Space wanted to build a cloud computing solution and use an AWS Snowcone to demonstrate edge compute and storage capabilities to support notional ML object recognition workloads in the International Space Station. So we partnered to kind of deploy a Snowcone in the International Space Station, really pushing the boundaries of the edge. This has been a particularly exciting use case that we worked on earlier this year. The last use case that I'll talk about was about the use of AWS Snow devices to safeguard Ukraine's data earlier this year when the Russian government invaded the Ukrainian territory. The AWS disaster response team, along with AWS public sector, collaborated with the Ukrainian government to migrate petabytes of critical government and commercial data to AWS cloud. We continue to make investments and working with our customers for all sorts of use cases, ranging from telecommunications to disaster response to hazard detection and safety. That's all I had from my end on the AWS Outposts and Snow. I want to invite Matt Johansson from AWS disaster response team to talk about some of his work, some of the work his team has been doing to support communities throughout the disaster lifecycle by improving access to AWS technologies at the edge. Thank you.
Thanks, Nida. Good morning, everybody. Thank you for being here. It's not a small thing for you to be here early in the morning on Friday, I gotta say. Everybody have fun at the party last night? Yeah, show of hands, cool. So my name is Matt Johansson. I'm the global lead for AWS Disaster Preparedness and Response. As the Snow team, Nida and Bassam mentioned a few of the things that we've been up to. Just a quick show of hands. Who saw the Jeep at Caesars Forum this week? All right, a few. Happy to answer any questions about the Jeep. It has been demobilized and secured last night, but if there are any follow-ups about that, I'm happy to take them. So the AWS Disaster Preparedness and Response team is part of the AWS Global Social Impact team. And our role is really to support communities throughout the disaster lifecycle. That includes both preparedness and response. So Nida mentioned some of the work we've been doing in the Ukraine, but we work all over the world with customers and partners to increase access to AWS services, technologies, and our people. So one of the biggest things that we do is maintain a very large list of technical volunteers where employees can actually go out with customers and partners to augment their response. So you can imagine if somebody needs a snowball, but they don't know how to use it, one of our volunteers might be able to help in the field. The other thing that we do, and that I'm going to talk a little bit more in detail about, is we do a lot of proof of concept development. So we're highly engaged in innovation because this space requires a lot of very detailed working backwards in challenging environments where there might not be any power, there might not be any connectivity. There's N challenges after a hurricane comes through a community that we're trying to solve every day. So one of the first things I'd like to share is a mechanism that we developed to increase our ability to work backwards from these challenging environments. We recognized that we were doing a lot of our development in our home offices with our warm latte, and it turns out that's not the best place to build solutions for a response environment. So we created the field test exercise program, where we go out for 2 to 3 days at a time with our customers and partners into the field and set up end-to-end scenarios for testing our proof of concepts. We invite builders to build on the fly, just like people would be expected to do in the field during a real response. This is a failure-safe environment. If it doesn't work, this is the right place to test it. We use rugged terrain. So most of the places that we go require a vehicle like the one some of you saw at Caesars Forum. And again, the focus is on increasing collaboration in these challenging environments and continuing to iterate. And obviously, we bring the snowball quite a lot to do that. And one of the biggest workloads we've been helping customers with recently is UAS mapping at the edge. So this is the idea that you can use a small quadcopter or drone to take pictures of the Earth and create a new map quickly. But we can do that at the edge with the snowball. So these data sets are very large. As the cameras get better and better on the drones, the data sets get larger and larger. So because especially the new version of the Snowball Compute Optimized with the SSDs, and it's got 104 vCPU in it, we can process new 2D and 3D maps quickly in the field without having to have a really good connection back to the cloud. Now, when mapping is complete or when the team has demobilized, the data can be saved to S3 on the Snowball Edge device and then imported into the cloud environment when the device is returned. This is really powerful for non-government organizations and nonprofits that are often called into these communities to provide situational awareness, and these maps really help quite a lot. We also try to focus a lot on the workload and getting ahead and looking around corners for our customers. It turns out there's really great open source software for this that can be built and configured in the cloud and then pushed to the Snowball Edge. So you can imagine configuring an EC2 instance to run this workload, which presents as essentially a web application. And once you get it working in the cloud, you can deploy it to the edge very quickly. So we're working with customers to maintain that inventory of application machine images that they can bring with them that serve as tools in the field. And again, depending on the needs and how much area needs to be covered will dictate how many snowballs you need to bring with you. Is it going to be one team that's processing multiple pilots worth of data? Is it going to be separate teams that need to spread out and do individual processing workloads? The Snowball Edge gives you the flexibility to really tailor your response that way. One of the other things we've been looking at quite a lot is volunteer safety. So take Hurricane Ian, when my team deployed alongside of our standby partner, Help.ngo, who's a non-government organization that focused on rapid response. We were only one small piece of the response, and there were dozens of groups in the field. So how do you keep, if you're a state or a federal agency, how do you maintain situational awareness across volunteer organizations when everybody might have different network posture, different devices in their pockets, right? We've been looking at integrating IoT capabilities and Snowball Edge to do this in a disconnected way. So apologies for not having one of these sensors in my pocket. We packed it for shipment last night, but we're using LoRaWAN sensors, so it's the idea that I can hold an inexpensive GPS receiver in my hand, and it communicates position over 10 miles from that sensor back to an IoT gateway that can be connected to the Snowball Edge. The point is, we can get a dot on the map for a person, a team lead, a vehicle, a UAS platform, anything, and no configuration, login, anything required. Show up in the field with a box of sensors, and you know where people are. Similarly, we're working on prototypes for pulling in ADSB data, AIS data, APRS data, almost any sort of RF you can imagine that has position location information that can be processed by the Snowball Edge, and then the workload to show that to end user devices, all completely disconnected. So imagine your phone, you can see where other teams are, you can see where critical resources are, and we're trying to make work that the United States government did to open source something called the Android Team Awareness Kit, a first-class citizen in the cloud and at the edge. So I'd just like to share one other example, and that's object detection. So I'm sure everybody in this room has seen an object detection demo, right? Computer vision and what these algorithms can do very quickly, and they continue to improve. But what I'd like to share about this example is kind of putting all of these pieces together, which is my team was deployed at one of our field test exercise events, and we were talking to our customer after the first day. And we were trying to ask for new challenges. We had completed the objectives of the first day, and a customer said, we're really interested to use object detection at the edge for urban search and rescue and mountainous terrain search and rescue. Do you guys have any opinion on that? And we sat down, we said, well, yeah, why don't we run it on the Snowball Edge? We have a Snowball Edge with a GPU at the bottom of the hill. So we started thinking about it and iterating, and we needed the Snowball to not be at the top of this hill because we hadn't built our Jeep yet. We had no way to power the Snowball Edge in this particular location. So we got the radios out, we started looking at a comms path from the top of this hill, which is about 3/4 of a mile away, to stream the data from a flying UAS platform, in this case just a commercially available quadcopter. The Snowball Edge had the model, the orchestration, et cetera, but the biggest challenge was the underlying Docker containers for this AI/ML model were not on the Snowball. Right, so that's lesson number one. If you want to do something basic like object detection, make sure you have the right prerequisites already on the Snowball. So we didn't have high throughput SATCOM. So we literally, at night, had to drive back to a place about 45 minutes away where we could download those containers and come back for the morning to implement this, right? So in real time, however, once we got this all working, we're able to transport and compress the video, do the object detection, stream the output back to that situational awareness platform, and then basically archive all of the video. So it's just one example of how you need to put together the end-to-end solution. It's not just about the example for using an algorithm like YOLO. You have to actually get the radios out and put it end-to-end so that your users in the field can actually get some value out of it. So that's the last example I have. I think we're going to take a few questions. So I'm going to invite my colleagues back to the stage, and happy to take any questions.